Hey guys, and welcome back. Today we're going to be covering the addition rule for probability. And I don't want to waste your time, so let's go ahead and dive right into that content. So what is the addition rule? Well, there's actually two versions of the addition rule, and we're going to look at that in just a second. But let me paint a picture for you first. The addition rule is a probability question where you have one situation happening, but you're trying to look at the probability of multiple outcomes occurring. So if I'm rolling the dice, instead of just looking at the probability of rolling a 3, I'm going to be looking at the probability of rolling like a 3 or a 5. If I'm drawing cards from a deck, instead of looking at the probability of just drawing a red card, I'm going to be looking at the probability of drawing a red card or a face card. So it's when you're looking at multiple different outcomes and trying to find the probability of those occurring instead of just one individual thing. As mentioned before, there's actually two different forms of the addition rule. One deals with events that are mutually exclusive, and the other deals with ones that are not mutually exclusive. Now, what the heck is mutually exclusive? Well, let's go ahead and dive into that, and then we'll jump back to the addition rule itself. So mutually exclusive is this whole idea on if I have a situation happening and I have a bunch of outcomes and I start talking about these outcomes, if any of the outcomes can occur at the same time, then we call that as not mutually exclusive. But if the groups of outcomes we're talking about can't occur at the same time, then that is mutually exclusive. Now let's go ahead and take a look at an example of this. If I am rolling a die with 6 sides on it, and I say event 1 is, or A is going to be rolling a 3 on that die, event B is rolling a 4, there is no situation where I am capable of rolling a 3 and a 4 at the same time. Therefore, a 3 on the die and a 4 on the die are going to be mutually exclusive because I cannot get the two at the same time. Now, let's talk about collecting a bunch of data. If I have a bunch of data I'm collecting about students at a university that are there for nursing or not, and I say, hey, I want to see if I can randomly select a male student, and I want to know if I can randomly select a student who is a nursing major. In that case, there's the possibility that I would grab a student that is both a male and a nursing major. So if that's the case where I could grab one student that falls under both categories, it's not mutually exclusive. So let's go ahead and jump back to the addition rule and see where this fits in. As you can see here, there's actually two versions of this addition rule. One has to do with that they're mutually exclusive. The other is that they're not. The easier one to do is if they are mutually exclusive. Because as you can see down here at the bottom, all you do in that case is just add the two probabilities together. So if I'm rolling a die when I'm trying to see if I can get a 3 or a 4, well, the probability of getting a 3 is 1 out of 6. The probability of getting a 4 is 1 out of 6. So I just do 1 over 6 plus 1 over 6, giving me 2 over 6. And that's going to give you the probability that either one could occur. Now, on the flip side, it's a little bit more challenging when there's an overlap, because what would happen is I would count all of the possible options for the first event, like, for example, drawing a red card, and I would count all the possible options for drawing a face card. The problem is those cards that are both red and a face card will get counted twice when I'm adding the probabilities together. For that reason, this form of the addition rule has to subtract that overlap. Because we are counting it twice, we have to subtract one of those two so that it doesn't cause issues for our final probability. We're going to take a look at some examples for this, so don't freak out if you don't fully grasp that idea just yet. So let's go ahead and look at this first example. So here it says you select a card from a standard deck, find the probability that the card is a 4 or an ace. Well, I know that there are 4 4s out of the 52 cards. I know that there are 4 aces out of the 52 cards. And I know that I can't have a 4 and an ace at the same time. So this is mutually exclusive, meaning we can just add the two together because there's no overlap there. I can never have both a 4 and ace at the same time. Once I add the two of these together, it would give me a final answer of having 8 over 52. Let's go ahead and take a look at another example. In this case, we're rolling a die. So how many options do we have on a die? Well, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. It says find the probability of rolling a number that is less than 3 or rolling an odd number. In this case, our numbers that are less than 3 are 1 and 2 over here. So there is actually a 2 out of 6 chance of getting a number that is less than 3. Now, an odd number, on the other hand, would fall into being the 1, the 3, or the 5. So there are actually 3 out of 6 options in that case. But if you notice, the number 1 fell in both categories here. So that means one of my 6 options was an overlap between the two situations. So that means 1 out of 6 of them got counted twice. The one got counted with the numbers less than 3, and the one got counted with the odd numbers. For that reason, we have to subtract it off after we add the other two together, because I don't want that to be counted twice in my final answer. So when we do this, 2 plus 3 is going to give me 5, minus that 1 is going to give me 4 over 6 as a final answer. Now, for the sake of this video, I'm not going to reduce these answers just to keep us moving through. The addition rule actually works for empirical data as well. So in this case, we have a chart of how many months they reached a certain amount of sales. Now, in this case, I can't have 2 different sale amounts in 1 month. So this chart would be mutually exclusive. So that means if I want to find the probability of multiple ranges, we just need to add those frequencies together out of our total. Because we are dealing with 3 years, that would be 12 months each year, we're looking at a total of 36 months in 3 years. Now let's go ahead and look at the question. It says, what's the probability that's between 75,000 and 124,999? So that would be looking from here up to here. So if I'm looking from 75,000 to 124,999, then that means I'm going to be looking at these two numbers here. So first off, that first group is going to be 7 out of 36, and then I'm just going to add that 9 out of 36 to give us a final answer here of having 16 out of 36. And remember, we don't have to subtract any overlap here because we would never be able to have 1 month that fell in multiple categories from over here. So now we're looking at a two-way frequency table. In this case, we are dealing with empirical data still, but some of our data and events are going to have overlaps and not. So in other words, we're going to be dealing with not mutually exclusive and mutually exclusive stuff. So let's take a look at what we have here. We have 4 types of blood, either O, A, B, or AB, and that blood can either be positive or negative. Now, when we're looking at these actual questions, it says, hey, what's the probability that one of these people has either type O or type A blood? Well, I know that there is a total of 409 people in this survey. How many of them have type O blood? Well, in this case, 184 of them have type O blood. So I'm going to up here put 184 out of the 409 people. Now, with that said, we're going to be adding our type A blood. Type A, it says that there's 164. So I have 164 people that have my type A blood. Now, type A and type O don't overlap. You can't be both. So we don't have to worry about this whole idea of subtracting in this case. So we just need to add across the top, since we have the same number on the bottom, to give us 348 out of that 409, and we would be done with this question. Let's take a look at number 2. Number 2 says that we're looking for type B and we're looking for negative. So in that case, I am looking at type B stuff, which would be right here. And I am looking at my RH negative, which would be this whole row right here. So in that case, let's take a look. We have 409 still total. Out of the B, I would have a total of 45 people. Then out of my negative, I have 65 total there. So I'll add that 65. Now the problem is here is that this 8 right here in the middle, this guy that I've covered up a bit, this 8 is both type B and negative. So this would not be mutually exclusive, which means I have to subtract that overlap of 8. Now if I have 45 and 65, that gives me 110. So minus that 8 is going to give me 102. And that final answer is still going to be out of the 409 total people. So for part 2, we end up with 102 over 409. So hopefully this helped you understand a little bit more about the addition rule. Remember, the big point here is you need to consider if it's mutually exclusive or not. If you have an overlap, you have to make sure you subtract that overlap when you're looking at the things you're adding together. Otherwise, you can just add the two probabilities together and that will give you your total probability. I hope you found this video helpful, and you can check out some of these videos over here if you want to see some other content that has to do with probability and statistics. Remember, my name is MrCaproni, and I hope you have a fantastic day.